Hello and welcome everyone to this very special IGA webinar. My name is Andrew Krauss. I'm one of the IGA co-founders, and Stephen is the other IGA co-founder. Raise your hand, Stephen. Give him a wave. Okay, great. And we have a couple great guys on for you tonight. Konstantin Dolgan and Matthew Williams. Konstantin is the CEO of LANPDT.com, and Matthew is an engineer. And they're going to be talking about a topic today, Stephen, that I don't think inventors are interested in this topic at all. Now, you know, prototypes. Of course you guys are. You guys are fascinated with prototypes, obsessed with prototypes, tormented by prototypes. I think it's going to be a great webinar tonight. And we have Konstantin and Matthew here to share with you what they know about prototypes. Stephen, do you want to do an intro of them too?
Well, first of all, I want to say I love prototypes, and I'm sure if everybody could raise their hand, they would say they all love prototypes too. And it's truly magical to come up with an idea that maybe in your head, and then maybe you sketch it out, and then you build it. There's something incredible about that experience, and I think every inventor, every creative person knows what that feels like. And of course, they want to share that prototype. I'm sure they're showing it to their family and friends and driving everybody crazy with the thing. They're probably even sleeping with it under their pillow at night sometimes. I know how crazy we can get with these prototypes.
That's just weird, Stephen.
Well, you know, I know what it is.
Look at they open the tooth. My daughter's 6. We just put a tooth under her pillow.
Your baby.
And guess what? The tooth fairy forgot to put money under her pillow after she lost her tooth. So the next night, my wife doubled it. So I don't know. So if you put your prototype under your pillow, do you wind up with a licensing agreement or your product in stores? What happens there?
Maybe funding. Maybe you'll get funding for your startup.
Yeah, you heard it from Stephen Key. Put your prototype under your pillow. Anyway, sorry, guys. Go ahead.
Make a really great article. But tonight, I'm really happy because what I'm seeing from my experience is that more and more companies, once they see your product and they want to license it, they want a prototype. Okay. And we're just seeing that. And of course they do. Of course, everybody wants to see when they want to see proof. Mm-hmm. And I understand that. But tonight we're going to talk about why are prototypes important? Because they're important for a lot of reasons. They're important. But they're also, we got to figure out when's the right time to build them and how to build them correctly and how to work with companies like LA, New Product Development. And they're going to tell us what's the best way to work with a company like this to get those prototypes that you need. So this is really kind of an exciting time for me because I love prototypes, but I was making prototypes in the day out of paper and out of clay and out of fabric, when today the whole world has changed. So why don't we jump in? The first question I'd asked Konstantin early on, why are prototypes important?
Well, Stephen, Andrew, first of all, thanks for organizing this webinar. I think it is important to understand why prototypes are important. And Andrew, if you don't mind, can we go to the third slide?
This one?
Yeah. So let me back up just a little bit. So like we start with an idea, then just in our head, right? So the next step, typically, if you go to the next slide, we typically convert our idea into a visual format, and that could range from hand sketches to professional drawings to 3D models, and to basically creating kind of like a virtual or computer prototype. And that one can take you far, but sometimes you actually need to build a physical representation of your design. And that's when we start talking about a prototype. And if you go to the next slide, basically what a prototype, what the process of prototyping is turning your visual representation of an idea into a physical model. So now we can actually like hold our idea in hands and interact with it. So why is it important? Andrew, do you mind going to the next slide? So first thing is, like you already mentioned, is you want to verify or prove your concept. And maybe for you as an inventor, there is nothing to prove, but your potential investors or customers may want to see that your idea actually is going to function the way you claim it's going to function. And you can do only like that much on a computer. You can do simulations, animations, and things like that. But at the end of the day, that doesn't really it's not a hard proof that it actually is going to work. So the first thing you want to, the first reason you want to build a prototype is to basically like show, yes, this is going to do what I'm saying it's going to do. That's the first thing. Second is product development doesn't stop on the first prototype typically. It's the iterative process. So really what you want to get from that first prototype is you want to get some feedback. And the first feedback you'll get is like when you're gonna touch this object and basically interact with it, you'll see whether the dimensions are right, whether the color is good, whether the shape is right, if it lays in your hand. Like let's say I'm developing this mouse, like if it's like if you put your hand, how it fits in your hand, and things like that. And you want to test assumptions that you may had before you actually build a prototype. The other reason is if you want to evolve your design, you want to evolve your idea. So let's say I start with one idea, but then like I interact with my prototype and I see that, I can actually make it a little shorter, a little larger, and things like that. That will improve its functionality or look or ergonomics. And that would actually make my product better, not only for myself, but for my future buyers and for people who will actually consume that product later down the road. That increases the value of your idea, of your design, of your product eventually. And yet another reason, which became a reason recently, is many crowdfunding platforms, like if you want to start a crowdfunding campaign, they actually like require people who want to start a campaign on a physical product to demonstrate the model. So one of the major crowdfunding platforms, actually, like that's one of the rules. You have to show pictures of an actual product. So renderings are not going to do that anymore. So now you actually have to show that you built something and you tested. You already passed the first stage.
One thing I want to add, thank you. For me, I think building a prototype, as you said, really teaches me what works and what doesn't work. And it allows me to get the feedback from people maybe using it. But it also allows me to fine-tune my intellectual property. And that could come in the form of a design patent, the way it looks. Right. That could come in the form of a utility patent, the way it functions. It also allows me to write a provisional patent application in such a way to include variations that I discovered, stop workarounds. It's a very useful tool, right, of really many different ways, as you said. And of course, from a licensing standpoint, when a company likes your sell sheet, okay, and the next call you get, the next thing out of their mouth, and they're always going to say it, do you have a prototype? Okay, because
yes,
we at InventRight like to test the market first a little bit to see if the idea has a benefit that's strong enough that companies show some interest that give us kind of a green light to start that process of building a prototype.
Exactly.
So thank you very much. I think they have a tremendous amount of value.
And sometimes, Stephen, it's just obvious. Company says, do you have a prototype? And you're like, well, I just take this product, put a hinge on it. And you could do it, or they could do it. So it's not always necessary, but it really depends.
It depends on the complexity.
Yeah.
Right? I mean, we talk about simple ideas all the time at InventRight. We talk about simple ideas at IGA. We talk about simple ideas, small improvements on existing ideas. But even those small improvements still need to be tested at times, right? And they
Yes.
needed to be kind of like, hey, is this really going to work? So
Mhm.
I think, I guess the point I'm making is that when you're required to make this prototype, that's why we're here tonight. Okay.
Yep.
Or,
I think
what
I
do
got
I
one.
do next?
if you're venturing the product, Stephen, you don't have a choice. If you're going to make the product and sell it yourself, you need to make a prototype. Damn it,
Well,
that's not
but
even
those
an
are a bunch
option.
of crazy.
Yeah.
Those are crazy startup people. But
No,
Matthew,
well, we cater to everybody at IGA,
yeah, we
venturing,
do.
licensing.
Matthew, what were you going to say? I'm
So
sorry.
there was one thing that popped in my head as far as another necessary reason why you want to do prototyping is what is it, the expectations of from your product, like what's what is it that you need to prove. And it I guess where I was going with this is sometimes the feel of the product is something that you're trying to improve, like maybe the ergonomics, and that's where something that it requires you to actually build a prototype, for you to have it in your hand, to be able to to manipulate it and see how this feels in order to assess it. I mean, if you're going for a certain look, sometimes it's necessary to do a prototype. We've had several situations where we would focus on a certain look when developing the CAD model, and then when we actually printed it out, it had a totally different look to it, and it had because of like how the computer screen stretched out the image and things like that, it had completely different proportions. So there's also some other reasons where a prototype is really a necessary thing.
Well, what's interesting? There is one of the categories, a kitchen category, where there's a lot of companies that are they're taking everyday objects and just making them easier to use.
Mhm.
And that has a lot to do with how they feel, how you use them. And so that's where I think you really have to dig in a little deeper and produce that and prove that's why consumers are going to want that over the existing product that's on the market.
Mm-hmm.
Yeah.
And I mean, luckily we have different types of prototypes these days, and each of them serves a different purpose. And you don't need to build a Mercedes type of a prototype when you can get away with a Volkswagen. Sorry for my analogy, but and and there are generally like three types of prototypes, and you actually did a great job describing that in your book in one simple idea. I even put a page number here that describes this in more details. But if you would go high level, like describing each of them, like from generally speaking. So the first type is the looks like type of prototype, or we also call it eye candy. That's basically like something that looks like your final product. You can gauge the shape and sometimes like how it's going to feel. But if there is a functional aspect of that product, you're not going to see it in that type of prototype. It's only basically like for a visual representation, and sometimes for some like feel and touch type of for sensation of that. So yet another that looks like prototype is also sometimes called a mock-up prototype. And that's a relatively inexpensive type of prototype. Even like a very expensive product that would be very expensive to make or build a prototype of can be simplified to where you can show the representation of it, and that may be sufficient enough for you to raise money, for example, like from your investors. Like we have one customer, like his prototype would cost like several hundreds of thousands just to build it. So there is no way like he can invest that kind of money without raising them from investors. So what we had to do for him is to build a mock-up prototype. It's basically like a demonstration model that he can show to the investors, and so they would have a better understanding of how everything would go together. Your product, yeah. What's up, man?
There's one thing I was going to add to it. In our experience, a lot of investors or other people like sometimes like a lot of us that are in this field like take for granted, understand some people's inability to imagine things, to be able to envision what what we're envisioning. And so that to have something for them to look and interact with is that's typically the first time they actually are it clicks with them. They then now finally understand what you're trying to achieve, by actually having it in their hands, or having some sort of way in which they can see it.
I have a question. People are probably going to ask, looks like eye candy. What is that? Is that a sketch, 3D model? What's typically the way to present looks like in your world?
So one of the things that I associate with when it comes to this is there's certain types of 3D printers that are called binder printers that are they bind a powder together, and they're able to print with many different colors, and is able to produce a very visually appealing prototype. Where it looks absolutely fantastic. It's crisp. If you were to look at it from afar, it looks like exactly what it'd be when it rolls off the factory floor. Now, the thing with that is that with the material that they're making with, it's a very brittle material. It shatters very quickly and whatnot. So it's not one of those things where if you're actually wanting it to perform a function, it has to have some sort of movement or things like that. Then it's not ideal for you to go that route.
Matthew, I'm curious about this. This looks like this first one. We typically like to think of a looks like would be a sketch, but you're saying this is an actual prototype you can touch, although it's fragile, but it doesn't function, but it gives you an idea what this is going to look like. How expensive is that? Because everybody wants to know at the end of the day some estimates. Can you give us an idea what that costs?
That's a tough one to talk about. I mean, typically when I'm thinking of those printers, they are on the expensive side, but I mean, it would be less. It would, in my experience, it would be less expensive than the works like, where you're actually trying to achieve the functionality of it. Where
it's definitely going to be a fraction of that. If you talk about the actual dollars, it can range from somewhere around like $50 for like a simple 3D print. All the way to probably like about $1,000. That's probably like where most of the looks like prototypes end.
Can I ask you guys a question?
And
a lot of people, they get all excited about 3D printing because especially with a small product, it's very cheap. But what they don't understand is it's not the cost of the 3D print unless it's big. If it's big, it can be very expensive. It's the cost of the engineer's time to do the CAD work to create the STL file that you input to the printer. It'd be like, oh, well, I can print a book with my printer, but you got to write the book. And so can you talk a little bit about the difference between the cost of the printing and the cost of the engineer to design? And
there is another aspect here is post processing. So after you finish printing the part, sometimes you need to spend quite a bit of time actually like finalizing it to where it would look like what you wanted to achieve. And Matthew can probably like elaborate a little more on
that. Which part? You talked about several. You had several points there.
Post
processing. Yeah. So there's several different 3D printing technologies. There's what most people think of, where it's FDM, filament deposit method, where you got a hot piece of plastic, going through a hot nozzle, and it's going round and round and in the shape that you need, and building on top of each other. That's what everyone thinks of when they think of 3D printing. The thing is that when you are printing certain objects in certain geometries, is that you have to also, in addition to be printing the part, there's some scaffolding that is being placed on the build plate and rising up with the part, which then interacts and supports that those layers that are being printed up, which can leave a lot of marks, and it results in a lot of time that needs to be done in order to sand it down, make it look good. So
Okay.
that's one of the things with 3D printing that not many people really think of. They just think it comes out in exactly the part. Now there are technologies that are coming out to where that is achievable, and it's now finally getting to a point where it's accessible to some of the public.
Okay.
So,
Okay,
yeah,
good. So
you're
the
about to say
range,
something?
just to summarize, that looks like prototype is something that could be fairly fragile, but it looks pretty darn good.
It kind of feels like a porcelain is
Okay.
typically
Yeah.
how to describe
You
it.
look at
You
it,
know,
okay, it's sexy. It looks fantastic. Don't
mhm,
touch it. It's going to break. It does not
mhm.
function.
Yes.
Okay. And it could range, depends on the size, complexity, depends on the type of technology I'm sure a company has. I know you have a lot of the latest technology.
Mhm.
Maybe some prototypers don't have that technology. Is that something they need to ask beforehand, their technology of producing a works like?
Uh, okay. Say that one more time. I kind of zoned out for a second.
I'm just saying, I want a looks like prototype.
Mhm.
Okay. And I'm not quite sure, how do I determine if the company I want to work with, such as your company, that they have the technology, because I know you have a lot of technology in your facility, that they're going to be able to produce that where it looks really sexy. I mean, do I have to, I mean, I'm not a technical guy. Do you just show it to me? You go, hey, this was going to look like, how
Uh,
does that?
so it's one of those things. I mean, typically our customers, if that's that they really don't even know to ask, a question like that where, I need like a looks like, a prototype. If they start off the conversation with something like that, then yeah, there's conversations that we can
Okay.
have, as far as what that is like. I mean, most people when we typically deal with some of the more complex of
Okay.
designs where it's usually very necessary to have a works like
Okay.
or
So
pro type of
most
prototype.
people bypass the looks like. Is that true?
Uh, Majority of our customers
Okay.
would do that.
Okay, so let's jump into the works like real quick, you guys. Works like is something I can has functionality. It's proof of concept.
Hmm.
How much more? I mean, how much time do you spend on that? I mean, this sounds like it's getting more expensive. Yes or no?
Yes.
Absolutely.
Yep.
But it
So
also again depends on the design. Like something simple like what Matthew like was holding in his hands. Matt, do you mind showing that prototype? Is basically just two plastic parts. So we are talking about maybe like $150 $200 of for building that kind of prototype, but it actually functions. So again, the cost will depend on like how complex your product is. And
so
if there is an electronic component involved to where you need to have like some circuit boards integrated into your prototype, then we start talking about maybe like even tens of thousands of dollars,
Okay.
depending on like how big it is, how complex it is, how like if we have to use some kind of like novel technology that we need to invent in the process. So the range goes like
Okay.
to extremes. Again, like we probably can still have something functioning within hundreds of dollars, but it can also like be like hundreds of thousands of dollars.
Okay.
For
so
So
example,
tell
if
me.
one thing
Go ahead. I'm sorry, Matthew.
So one thing I wanted to add, when talking about this specific product, this is actually the final product that was rolled off the factory, but we probably produced I think 50 different prototypes of this design, and it was mainly because of you can't see it here, but there's these little slots where you have this razor blade that goes up and down, where this lid will then flex, and the tolerances or the angle which we needed to have it to where it cut the tape effectively, was there's very little room for error. So we had to produce about 50 different prototypes of this design in order to get it to where it was cutting in a reliable fashion, where it also it receded back into underneath this lip here, the razor blade, when it was not in use. So that something was as simple that would seem as simple as this motion here actually turned out to be an incredibly complex thing to do when you were trying to achieve that, which is it's surprising.
Can we talk about size a little bit? I mean, that's a very small. You had to
yes.
put that 15 different times. If you have a product that's the size of a wheel of a car, that would get incredibly expensive if you need to print that 15 different times, right? Is that
yes.
Yes. You would probably not want to print it 50 times.
Right. So. Right. So that's something for people to keep in mind, is the size of the product is very relevant in a lot of cases of prototyping.
I have a quick question. So let's say I have a simple idea. You build a prototype for me. I like it. It works. And companies, and I'm working with a lot of companies, and they want to see it. And so I send one off, and of course they never send it back. Okay, so I'm going to need more than one here. So is it easy once you get it dialed in? Is it easy to produce like 5 of them for me?
Yes. Typically, it's once we've produced the first prototype, it's usually it usually takes half the effort, if not even less, in order for us to produce another one, because one of the things, especially with some of the more complex prototypes that have many parts that are being assembled together, what part of that process is you're learning how this is being this would need to be assembled during the manufacturing process. You're learning like all these little nuances about how the parts need to fit together, and typically if they need to make another prototype, it's much easier.
And so it's less expensive, because I'm going to need more than one here, guys. I'm going to need probably a dozen of them. Okay. All right.
Yes, it's usually much less expensive on the order. In the cases we've had, sometimes it can be sometimes is 10 to 25% of what the original cost was of the prototype.
And we have about 20 minutes left. You guys want to keep moving forward here?
Yeah.
Okay. Sorry, guys.
But one thing, like kind of like a trick I wanted to or like advice I wanted to give on that point, that when you work with a company that makes your prototype, negotiate like a deal on several of them from the get-go. You'll probably get a better price. Because they'll prepare like the tooling and the setup to make more of them, so the per part or like per prototype cost will be lower.
Okay. Good to know.
And it's a very rare case when you only need one. So
got it. Okay.
All right. So now, how do we go about building prototypes? And like Stephen, like you mentioned, in the early days, like you could use a paper or Play-Doh, maybe like or some other like wood planks and things like that. These days, the easiest way to build a prototype is to use some kind of rapid prototyping technology, which typically entails like either 3D printing or CNC machining. So something that you can program to build an exact replica of your design. And that's typically computer-controlled technology, which 3D printing is just one option. But some other rapid prototyping technologies include, like I said, CNC machining. So that's when you take a chunk of material and then you remove the unnecessary parts of it to where you kind of like almost like carve out what you need. The other technology could be silicon molding, which is especially effective when you need to make several pieces, so you could cast them relatively quickly. Matthew, I think you can tell a little more about like how does the process actually go, like from the point where people like approach us with their design to the point where they actually hold their prototype in hands. So what does it typically entail, and like what kind of information they would need to provide us?
So I mean, it's typically they come to us and it's a napkin sketch that they've made, and they've gone about as far as that, or and so what we typically start off is what we call like a concept design in our firm is, we're doing the CAD modeling. We're developing the 3D model of the product idea, and getting it ready. We're asking them all sorts of questions as far as like what market is this going to be in? What did they have any idea as far as the material, the feel that they need to have it? A lot of the times, they don't know what they don't know, and so we have to fill in a lot of the blanks where we have to make assumptions as far as what the high level descriptions they gave us. We have to then insert what other information needs to be answered in order to come up with a functional 3D model to where it can then be 3D printed. Is typically how we do that.
Well, wait a minute, Matthew. How painful is that?
How painful is the process of going from developing the concept
to work with those inventors to figure out what they're really talking about?
You know what? My experience, it hasn't been as painful as sometimes the prototypes is the more painful thing to get to realization than creating the actual CAD model. That's I don't know if that comes with our experience that we've had, where we have an idea with what works, but typically coming up with an idea in our head, from what they described to come up with the functional design, wait. Let me see if I understand this. Yeah, we're not ripping our hair out all the time.
Well, wait a minute now. Wait a minute. Sometimes inventors come with an idea. They're not quite sure how it's going to look or feel and build. It's pretty rough. And that must be a little harder to work with that group. There must be some people that know exactly how they think they want this to look too. And that probably drives you a little crazy as well. What would you like?
Both of those have their pros and cons.
Well, in a perfect world, what would you love to see? Would you love for them to come with you with what? To make your job
in a perfect world, I would love them to come with at least a decent sketch, have certain things marked out as far as what the function is, what they are expecting, but they don't what they have it to where that's how they want it to be, or it's kind of a high level what the function is. Exactly how we execute that isn't as of a big of a concern. That's typically
I would add ideal. To that references help.
Yes,
maybe
references.
You can show us some examples of what you want to see that has been done in some other products. That helps a lot.
That's
yes,
excellent.
That definitely helps.
Yeah, excellent.
We typically have a lot of different props in our office, in order to extract more information, where we're showing them different things and they're interacting with it, and we're asking them, okay, this is how you want it to feel like, this is what you wanted to do, things like that, in order to extract more of the information that we need.
All right, good. Okay.
Yeah.
So, because I think it's important for inventors to be prepared to really get what they want at the end of the day, right? Do you find that's important, because you want their expectations to kind of match what you're going to deliver, right?
Mm-hmm.
Yes. We try to make a great effort in explaining to them at the very beginning when we start, as far as making sure that they're we've prepped them as far as expectations goes in each stage before we do it.
Okay, good.
That's one of the things that we try to do, is really make sure they have a clear understanding of what to expect in each stage. So some of the things what we were about to discuss, like the different technologies, right, or current methods.
I think let's do like a quick overview of like what 3D printing looks like. What are some capabilities that we have these days?
Okay, so there's so many different capabilities now. You can 3D print. Let's see here. Let me go.
Well, conventionally, people, when people think about 3D printing, they think about some hard plastic objects, like what Matthew showed earlier.
They're thinking of something along like this here. but there's all sorts of different materials you're able to do now. Like say this was a 3D printed ceramic. So this was, this is a porcelain base that we were able to 3D print, now, and that's something that's unusual. This was actually 3D printed, not CNC machine. This is metal. This is
That's metal.
hard. That is metal.
That is stainless steel.
Stainless steel metal. You can you can start to see the layers.
Okay.
Mhm.
Okay.
So there you go. Here's another example of like a piece of ceramic that was 3D printed and it was glazed.
Wow.
We have all sorts of different material here. This is kind of more what people think of as well. We
Don't you
have.
love the show and tell? I love this.
Oh yeah. So this is some of the other things, like these are different materials in which you can 3D print. This is actually a sample of a new material that Form Labs came out with that's got a shore hardness of 50. I know that means nothing to most people, but
Hey, Matthew,
this is about as soft as you can get as far as this was 3D printed.
Show the wrench again, because that actually functions, right?
This does function. This is this was printed as an assembly in one piece, one print. So if you do the CAD model right, you can achieve this in most 3D printing technologies, especially the technology which is used to make this. So this is it's a technology called selective laser sintering, and it's taken a high-powered laser and it is melting powder into a hard plastic. So that's what this does, and is able to get really good resolution. And this has had no post-processing done. This came straight out of the printer, which is truly phenomenal. And you can print full, assemblies that articulate at a much higher level than say this would.
So what that technology enables is very important. What to stop here and think about, like what that technology enables these days is to print short run productions of your product. So not only like we are capable of making prototypes these days, but also like the latest machines that are like more advanced machines allow you to print parts that are good enough for the consumers, that you can actually like package your product and start selling it almost immediately. No upfront cost in terms of like molds or stuff like that. So no, like if you go injection molding, your molds can cost you somewhere between 10,000 all the way to 50,000 and even more. With 3D printers, you can start with a short batch, test the market, see how consumers receive it. Maybe they will suggest you some improvements. Then you improve your product, and then you start mass production. So like another method, basically, how you can launch your product with minimal investment in the beginning.
This is actually a part in which we are working with a client to achieve just that, where we'll be doing small batch with the printer we have here in the office in order to achieve that. There's all sorts of other things which you can do. This was actually 3D printed in this orientation. This is actually a mold that we use. We do a lot of silicone molding. And we were able to produce this with 3D printing technology. We 3D printed the mold, and we were able to pour silicone into it to achieve this. It's not perfect, but we can get this to where it's really close. This is a prototype, so this is actually what it will hopefully look more like when we get to actual final production.
Nice.
So there's all sorts of different things. Like this is more the hard plastic, but we were able to 3D print this to where this is in an assembly. So there's just all sorts of incredible things with this. We're able to infuse carbon fiber into parts. We have that technology here at the office, and we see more and more of our prototypes, our products that are having some sort of flexible material with it, for if it, if it's not doing a certain function, it's aiding in the ergonomics, the feel of the product of the product when it actually gets into someone's hands. So that's one of the things we
So
deal with a lot of our.
The technology for 3D printing is changing quite a bit, isn't it?
Yes, we're seeing a lot of disruption and a lot of changes that are happening very quickly with the 3D printing world these days. It's sometimes a challenge to actually keep up with
everything that
what's happening.
Everything that you showed us, Matthew, you have the capability of producing that there in your facility?
Everything except 3D printing with the metal. Like we don't do this in-house, but we have access to the technology in order to do that.
Stephen, we got a great question here from one of our attendees, I think for Konstantin and Matthew, that I think we should always address whenever we're talking about prototypes. Simon wrote, good for inventors to remember, though, that even if it can be successfully made in 3D printing, the design will probably need to be changed quite a bit for mass production methods and will require a lot more work and different expertise. So, I can see Matthew shaking his head. I know you guys are pretty technical.
Very good
point.
Talk
a little bit about that. Because you can make a prototype doesn't mean that this thing's going to make sense in mass production.
Absolutely, and that's also another reason for prototyping. One of the things that what we do is we when we know to expect that the product will in the end be produced using injection molding, is we start from the very beginning trying to produce parts that will what we anticipate can be done in using injection molding, and that's how we lots of times we need to try to assemble it using those means as well. And yes, you're able to the characteristics of a product as far as different dimensions changes a little bit when you transfer from 3D printing technology over into something is like injection molding. Each of them have their strengths and their weaknesses, and what we typically have to explain to a lot of our clients is when we've finished doing a prototype and and they're about to want to start with mass production, is like, okay, now we need to optimize this for manufacturing. And they look at us like they don't really quite understand what I thought it is. And there's a lot of things that is of a very technical nature that need to be done when it comes to wall thicknesses, the size of certain features, draft angles, overhangs, all sorts of things, like where do you put the part line for where the mold pieces fit together, like how will this be done?
So I have a question. So I think that's really a very, very important question, actually, because at the end of the day, you have to do we're looking forward to building products and scaling up and producing a lot of them. So when you're working with a company like yourself, what type of questions do you need to ask to make sure that they're building a prototype that's taking those questions into consideration? Like, how much experience do you have in production? Help us with that, because if you build me a prototype that looks pretty, but I cannot produce it, you're killing me.
Yep. So, I mean, the first thing you want to ask the engineers who are building the prototype is, all right, we're doing the prototype, how the product is actually going to be manufactured. So what would be the technology that will be used for manufacturing my product? So will we need to change the design for manufacturing, right? The other thing, it's important to ask what kind of material are we going to use for both prototyping and manufacturing, and how different are these materials? There are there is a variety of materials for 3D printing, but it's still like just a few compared to what injection molding has available, for example. So sometimes there are limitations in terms of prototyping, and sometimes you cannot show that hardness, for example, with the prototype. Just one example, for example, right?
Okay, go ahead. I'm sorry. See, what I want to understand though, I'm an inventor. I don't quite understand all the technology. Okay. And I know that I need a working prototype. At the end of the day, I want to make sure whatever I build can be produced. And I'm going to reach out to maybe your company or maybe another company. How do I qualify the company? Because I know you guys have a lot of background. You have a great reputation. You've done this before. But if I'm new at this, how do I qualify who I'm going to work with? What do you suggest?
If they say they can make a prototype using 3D printing technology that needs no changes for manufacturing, run.
Right.
That would be one of the things. It's almost very rarely, especially when dealing with injection molding.
Okay.
As I said before, there's different limitations. When what we do is we start from the beginning. We optimize our design in the concept stage to be 3D printed, and there's a lot of different things that need to be
but
taken into
Matthew, at the end
account.
of the day, when I buy a prototype from your company or some other company, you hand me the prototype. Do you hand me a CAD drawings that I can take to a manufacturer? How does that work?
Yes. So, and part of the process, when we make the CAD model, that is, you pay for that as your property, be able to do what you wish, and be able to take it to a manufacturer. We typically, in a lot of cases, we hold on to that CAD model, and we work with the manufacturers to optimize it, for manufacturing for that specific company we're working at, because each company actually has their own strengths and weaknesses when it comes to assembling and things like that. A change in the design, can drop the price in one company, but it may not be that much of a difference when work with another company, and that has to do with what equipment do they have access to and whatnot. So that's
But
one of the things that we.
I
I'll
would
let
also
you.
say like engineering background is important. People need to understand how materials work, and also like background in manufacturing is highly beneficial. And especially like there are so many manufacturing technologies, so you want to make sure that this prototyping company has experience dealing with manufacturers that actually like do that particular types of service. And you want to work with company who will be communicating with the manufacturer during the process. So it shouldn't be your responsibility, or like at least that's how we do it. We don't put it on the shoulders of our customers. We actually communicate with the manufacturer to make sure we act like translators. Basically, we tell the manufacturer what our customer wants to see, and the manufacturer tells us what they want to, what can deliver and things like that. So we kind of like act like as a mediator until like both parties understand the limitations and the expectations. So it is important that your designer does not disconnect from the process until you get a solid quote from a manufacturer that tells that how much it's going to cost to make this product. If once you get the quote, I mean, they by that time, a good manufacturer would review all the technical details.
Got it.
So
okay.
There's also another advantage to how we typically do things when optimizing the design for manufacturing is that because typically we've gone through the entire process of developing the design, making the prototype, and getting it ready for manufacturing. We understand where there can be certain sacrifices, certain changes.
Okay.
It is not going to change the quality or the function of that product when it actually is produced. Handing something off to a manufacturer that has not had that optimization done is very risky, and that's where you hear a lot of those nightmare stories where they have something, they've ordered a ton of product and it's not functional, but because that was not done.
Right.
And they have quality quality issues because the subtle nuances with the design had not been translated.
Okay.
Stephen, we need to wrap up, but Konstantin and Matthew, it's been incredibly informative for our IGA audience. I don't, even people that are experienced in this area, I think they learned something tonight. I think you help them think about how you're thinking, how the inventor should think. I think, Stephen, I think you asked some great questions too. I thought everybody did a great job educating our audience. So when they need to get a prototype, they'll be a little bit more knowledgeable, and I'm sure we'll be doing more of these on prototypes as well, Stephen. It's, as we all know, it's a very popular topic for inventors. So.
Yep. Yes, it is.
Yeah.
Everyone loves prototypes. Everyone loves.
We could probably do this for 8 hours, I think.
Oh yeah, you could.
Yeah, I know.
Yeah.
But this is a nice broad brushstroke overview. I think Konstantin and Matthew did a really good job. And there's, of course, there's things we didn't cover. We can't cover it all. You know, so much to talk about.
Yeah.
Is there any information where they can find you if they want more information? How can they find you? Is there a slide right there?
It's right there. There's a web address right on the top of the right-hand side of the slide there.
Okay, wonderful.
Yeah.
Okay.
Yep. LNPD.com. We have a feature on there where you're able to communicate with us via a chat application with a member of the staff, or you can email one of us. I mean, if someone, I'll just put this up here. I don't know if they can see my email address, Matthew@lanpdt.com.
That's pretty easy.
Very good. I see it. I got it.
And you're wearing a tie. Okay. You don't see engineers doing that very often.
Yeah, not very often. Yep.
Just for that picture.
So yeah, we make it a point to be accessible to our clients, to where they can ask us questions. You'll get the information that they need. That's part of the value in which we bring to them, in addition to doing the designing, is adding a lot of these other information to be able to help them make important decisions that we know they're going to need to make during the process.
Good.
So everybody, the audience, our members, we're doing this every month now. So we have prototype experts, patent experts, licensing experts, venturing experts from all different walks of life and different points of view. That's what IGA is all about. And so make sure to attend next month, right, Stephen? And the month after, and the month after. And membership to IGA will always be free, completely free to the public. And we're just going to try to find great speakers like Konstantin and Matthew here to come speak and educate you guys.
Thank you, Andrew. Thank you, Andrew and Stephen, for putting it together. I think you're doing a great job for inventors.
Well, thank you very much.
Yes. Thank you so much.
I just want to thank Andrew. Thank you for moving this along quite nicely. And I learned a little bit about prototyping. I know back in the day I was making my prototypes out of paper, but it's changed quite a bit. So thank you very much.
And you can still do that, Stephen. Some people still make prototypes out of paper. It's not easy to do. It's a talent, man.
Sometimes you can still get away with that. I won't lie. Sometimes you can, but
yeah,
not too often these days. But thank you, everybody, for joining us tonight.
See everybody. Take care. Keep inventing. Good night.
Bye-bye.